So we've looked at one method for calculating the natural frequency of the system. So let's look at an example of another method for finding the natural frequency of a system. And this one goes on the basis of the fact that we know that the natural frequency is found from the stiffness of the system and the mass of the system, and that we can use that relationship just to directly find the natural frequency of the system once we know the mass and stiffness. So let's take the example of a cantilever beam with a mass on the end. The beam we'll consider to be massless, and we'll look at displacing the mass on the end, basically pulling the beam down on the end and releasing it, and it'll vibrate up and down like a diving board or something like that. So that'll be our direction y that it's moving. The mass we know is m. The stiffness we don't know, but we can find stiffness from the equation of the load divided by the displacement of the load that the load causes. So if we can find that relationship, we can find our stiffness. If we look back at your strength of materials class, and we can know that for a cantilever beam, when you put a load on the end of the beam, we get a certain displacement. It's found to be PL cubed over 3EI. That's like in the back of your strength of materials book, so pretty standard formula for cantilever beam displacement. So if we want to find the stiffness of the beam, we take the load and we divide it by that displacement. And the P is the same, so the P actually cancels out. The stiffness is independent of the load. And we find that the stiffness is 3EI over L cubed. And if we know that the natural frequency of the system can be found from the square root of K over M, we can just plug that 3EI over L cubed for the stiffness and divide by M. And we have our natural frequency for that system. And if we had values for E and I and M and L, we could plug that in and get an actual number. It should come out to be in radians per second. So the E would be the material property of the beam. The I would be the moment of inertia of the cross section of the beam, and L is that length of the beam, and the mass is the amount of mass at the end of the beam that's being vibrated. So that's how you would solve the natural frequency in a more straightforward method.